Hello, ladies and gentlemen. Welcome back to math. Lately, or at least in this 6 weeks, we've covered a little bit of equations and its inverse of those equations, where you either move a variable, okay, sometimes you even plug in an equation inside of another equation to solve for those variables. Today, we're kind of still doing that, okay. The only difference is today we're going to deal with direct variation and its inverse variation, meaning the equations we're going to use today are for direct variation. For direct variation, we're going to use y equals k over x, okay? We're going to be given two variables. We're going to be given y. We're going to be given x, okay, to an equation. For its inverse, okay, the inverse of this equation is x, y equals k, okay? That's the inverse. You can also write it as, if we move this x over here, we can say y equals k over x, okay, because if we move the x. So there's two ways you can write it. You can either use it as this formula or this formula for its inverse, okay? The direct variation is y equals kx. So variations means that you usually have some ratios, okay, that you're trying to find what's the pattern between them. In other words, you're trying to solve for y and x are given to you. You're trying to solve for the k on these equations, okay? The k is a ratio, pretty much the pattern that goes into them. So, the problem for today means, or is, should I say, if we have a variation where y equals, okay, equals 9, okay, so we throw it into this machine, y equals 9, it converts it to x equals 6, okay? So we put it into a machine, we had a y equals 9, it came out as x equals 6. So we want to find the conversion of it. But it also tells us that if we throw in 8, x of 8, okay? This time we want to inverse it. We're going to throw it in. What's our y? Okay? Our y is, we don't know. That's what we're trying to find out. Okay? That's the whole problem. Well, that's the whole point of this concept. We're going to use direct variation because we still don't know what k is. Okay? Notice that it didn't give us any k's. Okay? So we know what y is. We know what x is. We still don't know what k. So what we're going to do is we're going to plug in the first one, the one that is completed. Okay? So we have 9 equals k, and then the x, which in this case is 6. If we're trying to solve for k, we move the 6 over by dividing. So k equals 9 over 6, which is known as, they're both factors of 3, right? 3 over 2. Okay? So k equals 3 over 2. Now that we know that we know what k is, we're going to do sort of the same thing. This time, we're going to plug in 8 and k to solve for y. So let's use another color here. So again, we're going to use this time this other equation. We don't know what y is, so y equals, we know what k is, 3 over 2. We know what x is. It gives us an x, which is 8. Okay? I like to always make it into a fraction. Since the number we're going to deal with is a fraction, I always put a whole number under. So we have 3 times 8. Any hints? 24, right? So y equals 24 over 3 or 2 times 1 is 2, which if you reduce it, always reduce it, guys, okay? We have y equals 12. And that is our answer, okay? So y equals 12 in this formula. You can also, okay, now we're going to find this inverse, okay? So again, you can use one of these two equations for its inverse. I'm going to use the top one, makes it a lot easier, okay? So we have x, y equals k. Notice that, again, if we're going to use the same problem, we have to find k, okay? So we have x and y. We have x, which is 6, times y, which is 9, equals k. Okay? 6 times 9 is, any suggestions, any hints? Did I hear 54? Yep. All right. So 54 equals k. Okay? Now that we have our k, again, we're going to plug it in for the second equation. Notice that we don't know what 12 is or what y is. We know x equals 8. So we can say, again, I'm going to use the first one. I like this one better than this one. So we can say 8 times y equals 54. Then we divide by 8. Y equals, any suggestions? Anybody? Let's see. 8 times 5, anybody? Is 40, right? We're looking for 54. So if we add another 2, which is 8 times 7, is 56. Notice that it doesn't really work out 100%, okay? What we're going to do instead is we're going to factor it by 2, okay? So 54 divided by 2 and 8 divided by 2. So half of 54 is 27 over half of 8 is 4. Since you can no longer reduce it because there's no more factor for them that are the same. Your answer is y equals 27 over 4. And that is your answer. Okay, so it's inverse. For y, for a direct variation, you have 12 and 8. For its inverse, you have 27 over 4 and 8. Okay? Make sure you write it all down. Make sure, again, you use both equations. You use a direct variation equation, which is your basic origin, and then you pick one of the two for its inverse. If you have any questions, guys, let me know, all right? So here's your assignment for today. Alright guys, your assignment for today is, you're going to find both, okay? The direct variation and its inverse. Your problems are x equals 15. Once you throw it into the machine, that converted it into a y equals 5. Okay? Now you don't know what x is. Okay, so let's try and find for when y equals 9. Okay? Remember, you're going to give me both the direct variation and its inverse. Okay? We're going to do one more just for practice. Okay? The second problem is I'm going to have y equals 16 when x equals 36. Okay? Therefore, when x equals 54, what does y equal? Okay? Remember, you're going to find both the direct variation and its inverse. Okay? So there's 2 problems. So a total of 4 problems because you're doing 2 for each. 1 direct variation, 1 inverse for each. Remember, guys, 2 different equations to use for inverse. There's one only for direct variation. Make sure you send me your answers as soon as you're done watching the video, and I'll be waiting for your email.